If we have a function f of x, according to the trapezium rule, we can estimate the area under the curve y is equal to f of x by dividing the interval a, b into n intervals or n number of strips each of width h. This estimated value will be approximately equal to the exact value of the area under the given curve.
Oh, this formula is pretty easy to remember because inside the bracket, we just need to add the first and last y values and multiply the remaining sum of numbers by 2.
That's a good observation, Prashana. Also, in general, if there are n trapeziums or strips, there will be n plus 1 ordinates. For example, if there are 6 strips, then there will be 7 vertical lines or y values, which we term as ordinate.
Okay, teacher, just to be extra clear, can we have one example?
Oh, certainly. According to the question, we can easily identify 2 intervals, or as we say, 2 numbers of strips. Similarly, the function y is equal to 6 over ln of x plus 2 is to be integrated from 1 to 2. So, the first thing we need to find out is the value of the width of strip h. This is equal to the difference of upper limit and lower limit divided by the number of intervals. It is now clear that there must be 2 strips, each of width 0.5 units, which means there will be 3 ordinates, each 0.5 units apart from the lower limit 1 to the upper limit 2. Likewise, depending upon the x values, we can generate corresponding y values onwards. Now, as per the trapezium rule, the area is estimated via this calculation. As a result, 4.84 is the estimated value of the given integral.
Finding this helpful? We have additional learning resources to offer. For Cambridge IGCSE and AS A-level subjects.
Is there any method to know how close our estimated value is to the exact value of the area?
Well, yes we do. And that is called the concavity of the curve.
Concavity? What is that?
The concavity will tell you whether your estimate is an underestimate or an overestimate. For example, when the curve is concave down, the trapezium rule underestimates the area, whereas it overestimates the area when the curve is concave up.
I see. So, if the top side of each trapezium lies under the curve, then it is said to be underestimated. And if the top side of each trapezium lies above the curve, it is said to be overestimated.
Very good. Let's go through one example now.
Sure.
According to the question, we should first calculate the width of each strip. Since there are 5 intervals, each of width pi over 10, we will have 6 ordinates within the interval 0, pi over 2. Now, using the trapezium rule, we get the estimated value of the area as 0.550. Similarly, to check whether our estimated value is under or over the exact value of the area, we need to sketch the curve y is equal to x cosine x and the trapezium. In this case, it is clear from the sketch that the trapezium rule will give an underestimated value of the exact area.
Wow, teacher, you did it all so easily.
And so you can too. Try this.
All right. To estimate the area of the region R from the interval 2 to 3, it is divided into 2 intervals as per the question, which means there will be 3 ordinates. Using what we have learned before, we can calculate the estimated area as such. In this way, we get the estimated area of the region R as 0.21. To identify whether the trapezium rule underestimates or overestimates the true value of the area of region R, the trapeziums are sketched on a graph. Since the graph is curving in a way that the chord lies above the curve, it gives a slightly greater area in each strip than the curve itself would in interval 2 to 3. Hence, the trapezium rule will give an overestimate of the true value of the area of region R.
Register now for free.